Now we got the engine apart, we want to find out what has to be done to get it rebuilt. And the first thing we're going to look at is the cylinders. And you can see them here. But we have to clean it and then check for taper, which is the most obvious wear pattern. You can see in this diagram that there's two measurements to be made and whatnot. There's also out of round, which is a little bit more rare, but taper is the most common wear pattern in a cylinder. So you'll need a inside micrometer or a bore gauge to do that. We're going to measure these cylinders with an inside micrometer. You have to be very careful. It's a delicate instrument, and you hold it with the long protruding rod, and you use your fingers to get the measurement directly across the bore. And you measure top, and you measure bottom, and then you turn it 90 degrees and you measure top and bottom again. Now the top and bottom has to be below the ring travel to find out the taper, and then when you measure the bottom, as in the diagram previous, you'll find out how much taper there is. The outer round will be the difference in the measurement from turning it 90 degrees. The original bore size is at the very bottom in line with the piston pin. That way there's been nothing touching that part of the engine, and that will give you the original bore. This one we found out was bored 30 thousandths over. So this is a rebuilt engine, and by the looks of everything, it was done very well. This inside micrometer was set up to read from 4 inches to 4.5 inches, and we find here it is 4.31 in a little bit. And the fact it was bored 30 over, that means, with this being the largest measurement, that the wear or taper is no more than 1 1/2 thousandths of an inch, and we found no change in the out of round, so it's not out of round, and there's the wear and taper are in specifications. Assessing the camshaft, we found the journals were in perfect shape. There wasn't even any scoring on them, and they measured okay. Then we wanted to find out how much wear in the cam lobe, so we measured the nose to the bottom of the base circle, and we found that we had 1.694 inches on the digital vernier caliper. So to find lift, we had to find out the base circle, and the base circle measurement is just across the base circle and at 90 degrees to the nose. And then when we measured that, we came up with not that reading, but this reading of 1.463, which left us with 0.231 inches of lift. Well, after the camshaft, we looked at the crankshaft. Now it's going to go down for polishing down to the engine machine shop, and they're going to do most of the assessment. We'd send all crankshafts down to the machine shop because they all have to be polished. So we measured the crank pin journal and then the main bearing journal. And through those measurements, they were such that we wanted to see if this crankshaft had been machined. So we took the bearing off and looked at it, and if you see there, it's 0.010 undersized. So this crankshaft has been machined, and along with it being bored, this was rebuilt probably at a professional place where they automatically do the first stage, which is 10 under for the crankshaft and 30 under for the cylinders. Again, we're finding this engine in very good shape. Well, we're going to have a good look at the pistons to assess the pistons. So far, this engine is assessing in a very good shape. You look in the ring grooves and you'll see carbon in there, and that all has to come out because the new rings will be larger and push back into that carbon. So you got to clean it with, the best way I've found is with an old ring, and you push all that carbon out so that the ring groove is clean. And you can look at the ring lands, which are the spaces of the piston between the ring grooves, and look for wear in there. But there wasn't any wear on these pistons. This operation on pistons has to be done carefully because the pistons are made of aluminum, and you can scrape aluminum pretty easily. So be careful and just get carbon out. Pistons have to be cleaned by hand. You can see the carbon on the side of the ring lands themselves and in the grooves. So you clean the sides by hand, and you clean the top by hand because the aluminum will flake pretty easily or wear pretty easy if you use any power equipment. We want to check the pin bore for wear with the piston pin, and you got to grab it and try and move it toward the top of the piston and the bottom, and when it's in the position that it is in the engine. So you move the connecting rod into the middle underneath and to where it's positioned in the engine, and you're looking for either solvent or brake clean in the clearance between the piston pin and the piston pin bore. If there's any wear at all, it will sort of push out the solvent or brake cleans, telling you that there's movement in there and they have to go down for service at that point. But this one, again, there was absolutely no wear. So far so good with this piston, but we're going to look at the piston skirt, both sides, and see if there's any abnormal wear patterns or whether they're off to the left or right. And we look at this pistons, as all the others were, the wear patterns are exactly where they should be, telling us that the connecting rod is not twisted or bent and causing some strange patterns to appear on the piston. This engine is proven to be in very good shape and telling us that it was rebuilt properly. The last thing we did was check the block deck to see if there's any warpage, and there was nothing. We used a 1.5 and a feeder gauge, and there was no, there was no spaces, and that was tight. The feeder gauge, we couldn't pull it out. And we did it in a crisscross pattern, and we tried in between each cylinder. So we found that this again showed us that the engine's in very good shape. A couple things to add here is that pistons are what they call cam ground. That's a temperature control. If you look at the top diagram here, the circle is like an egg, and this allows limited or a small amount of clearance when the engine is cold. As it heats up, the piston actually then becomes round, so that the clearance sort of comes in with the actual heating and expanding of the piston. Cam ground pistons have been around a long time, and it's an interesting way of engineering them. The other thing is the back of the ring, there's some back clearance, and that back clearance is where that carbon collects. So it's very important, and this is an afterthought in a way, so you can see it clearly in this diagram, that back clearance will pack with carbon. And with a new ring, and the red portion here would be larger in a new ring because there would be no wear, would be jamming up with the carbons that's in the back clearance. So you've got to clean that out. Other than that, this engine is showing us that the crankshaft, though it needs to be polished, is in good shape. It's been machined 0.1/1000 of an inch under. That the pistons are in very good shape, and we're going to clean them up and make sure that all the carbon's off. The camshaft, because of new technology, we'll probably replace that, and you always use new lifters when you rebuild an engine, so the hydraulic lifters will be replaced. And the block is not warped, so we have good cylinders, good crankshaft, good pistons, no sign of connecting rod twisting or bending, and we can now order the proper parts to complete our rebuild. Thank you.